In this video, we are going to learn how to use product to sum and sum to product formulas to establish identities. So we're going to establish each of these four identities using these formulas. We'll start with the top left example of sine of theta plus sine of 3 theta all over 2 sine of 2 theta simplifies to just cosine. So let's show how that is. So I'll have sine of theta. I'm going to start with this side since it looks like the more complicated side. And I'm going to show how I get to cosine. So first, I notice I have a sum of two sine formulas. So as a reminder, the sum to product formula for sine of alpha plus sine of beta is equal to 2 sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. So if I use this formula on the top, I'll get 2 sine alpha plus beta is theta plus 3 theta is 4 theta. Divided by 2 gives me 2 theta. Times cosine of theta minus 3 theta, which is negative 2 theta, over 2, which is cosine of negative theta, all over 2 sine of 2 theta. Now right away I can already see several things cancel. So the 2's and the sine of 2 thetas cancel. And I'm left with just cosine of negative theta, which by the even property for cosine, since it is an even function, I can eliminate the negative on the inside of that function, leaving me just cosine of theta. Now let's look at this next example where we have sine of theta times the sum sine of theta plus 3 theta is equal to cosine times the difference of cosine of theta minus 3 theta. So we can start on either side, but I'll start with the left side. All right. Now first I have a sum of two sine functions. Inconveniently, I have done the sine of theta plus sine of 3 theta, which I already know as 2 sine of 2 theta times the cosine of negative theta, using that sum of sine formula for that sum of the product. So now here I'm going to assess and think about my end product. Now I can see that they're all being multiplied, and I have found a cosine of theta right here. So I'm going to rearrange this to bring the 2 out front because that's a coefficient, times cosine of negative theta, times, now I'll put these two sine functions together, sine of theta times sine of 2 theta. But this isn't a cosine of negative theta, but this is an even function, so I can write that as 2 cosine of theta instead. But now this does not match the inside of this, so we'll have to use another formula. Now I have the product of two sine functions, which I can use a product to sum formula to make this product a sum of trig functions. And that formula for sine of alpha times sine of beta, since I have two sines being multiplied, that is equal to 1/2 of cosine of alpha minus beta minus cosine of alpha plus beta. So using that formula, I could rewrite this as 2 cosine of theta times 1/2 of cosine of alpha minus beta, which is negative theta for theta minus 2 theta, minus the sum of alpha plus beta, which is cosine of 3 theta. So now doing a little bit of simplifications. I can see the 2's cancel. And that cosine is an even function, so that negative inside of it, just like earlier, I can get rid of, leaving me with the expression cosine of theta times cosine of theta minus cosine of 3 theta, which is what I was trying to establish earlier. So sometimes I'll use a combination of sum to product and product to sum formulas. Now let's look at the top right example. I have cosine of theta minus cosine of 3 theta over sine of theta plus sine of 3 theta, which just simplifies to a 1 tangent of theta. So I'll definitely start with the left side since it definitely looks more complicated. And I can see already that I have a sum of cosines, so cosine minus cosine. So I can use that formula of cosine of alpha minus cosine of beta, which is equal to -2 sine of alpha plus beta over 2 times, not cosine, but sine of alpha minus beta over 2. And this can be divided by that sum formula, which again I have done earlier with sine of theta plus 3 theta, sine of 3 theta. I've used that formula earlier. But now rewriting this, I can get -2 sine of theta plus 3 theta, which is 4 theta, divided by 2, which is 2 theta. And then sine of theta minus 3 theta, which is -2 theta, divided by 2 would be negative theta, all over, I did this earlier, but using this formula, I can get 2 sine of 2 theta, because that would be theta plus 3 theta over 2, which would be 4 theta over 2. And then cosine of theta minus 3 theta over 2, which would be cosine of negative theta. And I can see here that my 2's will cancel, but it'll still be negative, and my sine of 2 thetas will cancel, leaving me with negative sine of negative theta over cosine of negative theta, which sine over cosine is tangent, so I get negative tangent of negative theta. And I do know that tangent is an odd function, so I can use that odd property to take out a negative, which will cancel with the one that's already there, leaving me with tangent of theta. And again, I might even write the reminders of all those even odd properties were. So sine of negative theta is negative sine of theta. Cosine of negative theta is just cosine of theta. And tangent of negative theta is negative tangent of theta. Just to remind you of those even and odd properties. Now let's do this last example. We have sine of alpha plus sine of beta divided by cosine of alpha plus cosine of beta is equal to tangent of the average of alpha and beta, which is alpha plus beta over 2. So I'm definitely going to start on the left side. But it's really nice formula to see here that these can all combine to one trig function. Sine of beta all over cosine of alpha plus cosine of beta. That is an S. I just accidentally wrote AC for a second. But now I can use my sum formula here to replace that top expression. So I'll get 2 sine of alpha plus beta over 2 times cosine of alpha minus beta all over 2. But now I have a sum of cosine, so I can use that sum to product formula for cosine plus cosine, which isn't this formula. So I'm going to write down what it is. Cosine of alpha plus cosine of beta is equal to 2 cosine of alpha plus beta over 2 times cosine, another cosine, of alpha minus beta over 2. So the denominator can become 2 cosine of alpha plus beta over 2 times cosine of alpha minus beta over 2. You can see here that 2's will cancel. And the cosine of alpha minus beta over 2, I have a 1 in my numerator and denominator, so those can cancel as well, leaving me with sine of alpha plus beta over 2 over cosine of alpha plus beta over 2, which I now have sine over cosine, but still using the quotient identity of tangent of theta is equal to sine of theta over cosine of theta. I can say that this is equal to tangent of alpha plus beta all over 2, which is what I was trying to prove in the first place. And that is how you use product to sum and sum to product formulas to establish identities.